You have now completed the lab Pythagorean theorem, where you kind of saw a shape that would have looked like this, where we had a triangle in the middle, a right triangle to be exact, and then over here they gave you a square that matched this side, and you colored it in. And then you had a square that matched this side, and it was colored in. And then you took those two together to make this square on this side. And so then we used all the pieces from the pink and the blue in order to fill in the purple. And the whole idea is that you were supposed to figure out that the area of this square plus the area of this square made the area of this square. And that was just a visual of what is known in geometry as the Pythagorean theorem. So to define the Pythagorean theorem is a little more difficult, even though it kind of makes sense. The Pythagorean theorem is a relationship among the three sides of a triangle where the square of the hypotenuse, guess I shouldn't have drawn that there, is equal to the sum of the square of the other two sides. So then we need to define a right triangle. So I'll kind of separate this off so you can see. A right triangle is a triangle with one angle that is 90 degrees. Okay. Then we need to define what the leg of a right triangle is. It's the same thing as a side, but more specifically, the leg is a side that is opposite or across from, opposite just means across, the acute angles in a right triangle. So then the hypotenuse is kind of the same thing, except for this is the side in a right triangle. That is opposite, or again that means across, from the right angle. So again, a hypotenuse, it's always going to be the longest side of a triangle, but it's always going to be across from, in a right triangle, across from the right angle. Because the Pythagorean theorem, this only works in a right triangle. Okay, I guess I should have said that. The three sides of a right triangle. So you need to know that it's a right triangle. Okay. And then the last thing that we kind of need to know about before we move into what the actual Pythagorean theorem is what is a Pythagorean triple. And a Pythagorean triple is going to be a set of positive integers Again, it can't be negative, so positive integers. And we're going to call them A, B, and C. That satisfy the Pythagorean theorem. And as you already discovered in your lab, you should know what the Pythagorean theorem is, but in case you don't, well, we're going to put it here in this box that says Pythagorean theorem, and it's going to be a squared plus b squared equals c squared. And then underneath, I want you to put a and b are legs, and then we're going to put that c is the hypotenuse. So the largest side will always be your c, because it should always be across from the right angle. And we learned this in our triangle inequalities, that the largest side should be across from the largest angle. And in a right triangle, the 90 degrees should always be the biggest one, because the other two should be acute. So if we were going to label our picture, okay, I'm going to use the same colors. This would be a leg. So we could use this as A or B, it doesn't matter. This would also be a leg, so we could use this as A or B. Again, it doesn't matter. So if I use this one as A, this is B. If I use this as B or A, then this is B. And then again, opposite the right angle, so over here, this side is the hypotenuse. So this will always be C in the equation. So let's look at example 1 and see if we can't set this up. So for example 1, this is a right triangle, so we know we can use the Pythagorean theorem. So again, it would be a squared plus b squared equals c squared. So I'm going to go ahead and use those same colors. So this would be a leg, and this would be a leg. So these are going to be my A and B. And then this is what I'm looking for, so this is going to be my C. So we'll mark that one in purple, if it's on. There we go. So that we can set this up. So then I'm going to use this as my A, and I'm going to use this as B. Again, it doesn't matter. And then we're going to use this as C. So when I set this up, my A squared would be 3 squared. Then I put plus, my b squared would be 7 squared. And then my c squared would just be x squared, because that's what I'm looking for. So find the value of x. So now we would just go through and work the problem. So 3 squared, 3 times 3, not 3 times 2. 3 times 3 is 9, plus 7 squared. So 7 times 7 is 49, and that's supposed to equal my x squared. So then I just combine like terms. So I would do 9 plus 49, and I would get 58, and that equals x squared. So then the opposite of squaring something is to square root. So to get rid of this squared, I'm going to square root on the right, and I'm going to square root on the left, so that the square root cancels with the square. And now I'm left with x by itself equals the square root of 58. So I can put that in my calculator, and I can double check it. If I take the square root of 58, it comes out to be a decimal. So what I need to do is see if it simplifies. So remember, we do our factor tree. So I've got an 8, so I automatically know that it's going to divide by 2. So I get 2 and 29. Well, 29 doesn't break down. I don't have any factors that I could put here, so that doesn't break down, and 2 doesn't break down. So that means this does not simplify. So my answer is just simply that x equals the square root of 58, which is approximately 7.62 is what the calculator said. So when you're looking for an answer, it could be this, or it could be this. And then just remember, if they give you units, like if they say centimeters, then this would be centimeters. Okay. All right, so let's try the next one. I'm going to try to fold this in half real fast. There we go. So now we're going to do example 2. Notice they rotated the triangle around. They want to make sure that you know what you're doing. So again, the legs are going to be this one, the 6, and this one, the x. Your hypotenuse is going to be this one. So this time we've got things in a little bit different place, because remember, this is a squared plus b squared, and then that's always going to be equal to c squared. So let's fill in our values. I'm going to use this as a and this as b. Again, it doesn't matter. So this would be 6 squared plus b, which is x, so x squared. And that's supposed to equal 6 root 2 squared. So let's see if we can start to simplify. 6 squared, meaning 6 times 6 is 36. Then I get plus x squared. And then over here it says I've got 6 root 2 parentheses squared. That means I'm multiplying 6 root 2 times 6 root 2. So I'm not going to mess with this side right now, but I'm going to keep going. So then 36 plus x squared. Over here, remember we do whole numbers times whole numbers. So 6 goes with 6. And then root 2 would go with root 2. So 6 times 6 is 36. Root 2 times root 2 is root 4. So now I can simplify. Again, I haven't done anything on this side, so I'm just writing it down. But the square root of 4, if you put it in your calculator or if you know it, is 2. So that's 36 times 2. So then I now have 36 plus x squared equals, and then 36 times 2 is 72. So now, remember, I'm trying to get the x by itself on this side of the equation. So then that means I need to move this over. And as many of you know, as I move it, it would become negative. So this would be minus 36, minus 36. So I now have x squared equals, I'm going to move it up a little bit here. There we go. Then if I do 72 minus 36, I get 36. So then now to get rid of the square, the opposite is to square root. So I square root on this side, square root on this side. So then the square root cancels with the square, and I've got x. And then the square root of 36, I get that x equals 6. Now remember, it is technically plus or minus 6, but we don't use the negatives in geometry. I even had my husband do it this time, and it still fell. Oh, we'll try again. Story of my life these days, guys. Sorry. Alright, so let's look at the back. We've got a couple more problems to work through. So example 3, find the value of x. What you need to notice is that this is not even a right triangle. But if I draw a line right here, I can create a right triangle where this would be the right angle. Now the problem is 11 goes from here all the way to here. So what I need to figure out is this measurement here. Well, if we look from here to here, from above, that's 5. So then from here to here, in order to make 11, this would have to be 6. And then the same thing from here to here is 8. So then if I transfer that over, this side is 8. So now I can actually isolate my right triangle. And I've got an 8 here. I have a 6 down here, right there. And then this is x. And this is my right angle. I hope y'all can hear my dog snoring because that's ridiculous. So now we're going to set it up. This is a side, this is our side or our leg, and then this is our hypotenuse. So as we're setting this up, a squared plus b squared, and then remember that's equal to c squared, we're going to fill in. So I'm going to do 8 squared plus b, which is 6 squared, and that should equal my x squared. So now I can kind of start to put things in the calculator to simplify. 8 squared is 64. Again, that's 8 times 8. Plus 6 squared, or 6 times 6, which is 36. And that's supposed to equal x squared. So now if we add those together, I get 64 plus 36, which is 100. So this would be 100 equals x squared. Again, I'm trying to get x by itself, so to get rid of a squared, I take the square root on both sides. So then the square root cancels with the square, leaving me with just x. And then if we put this in our calculator, we get plus or minus 10. Well, if you put it in the calculator, it's just going to tell you 10. So then the x in this equation, or in this problem, would be 10. So then they might ask you to find the perimeter of the trapezoid or something like that, and I could do 5 plus 8 plus 11 plus 10, or whatever they ask me for. Good. So now let's try number 4. Number 4, they're going to try to trick you up a little bit. So on number 4, fold this again, I get tired of fighting with it. They give me this picture. Nova. Gosh, he's ridiculous. I'm sorry, y'all. So when I go to set this one up, you should see a right triangle if you just look at one of them. So I could do this one here. Alright. Y'all hold on just a second. I'm going to go wake up the dog. Hey, Nova, stop. You're snoring through my video. I know I'm boring, but geez. Okay, sorry. So if that's the triangle, again, remember these mean that all the sides are congruent. Those are our hash marks. So if this is x, that means this is x, and this is x, and this is x. And I only have to solve for one of them, but we need to know that they're all the same. So again, if I isolate that right triangle and I pull it out, here's the right angle. We've got this marked as x, we have this marked as x, and then the hypotenuse right here is listed as 5 root 2. So again, this would be a leg, this would be a leg, this would be my hypotenuse. So I set this up as a squared plus b squared equals c squared. And then both of these would actually be x. So I'm going to do x squared plus x squared. And then that's supposed to equal my c, which was 5 root 2 squared. So now we can kind of start to simplify. If I have an x squared here and an x squared here, that's like having an apple and an apple.